Okay, so for today's lesson, let's continue with 4.7. We were talking about inverse trig functions the other day. So let's go over some of the things that we talked about, and then we move on from there. Okay, so just to refresh your minds, we talked about the inverse of sine, inverse of cosine, inverse of tan. Okay, so the domain for inverse of sine is -1 to 1. The range is -π/2 to π/2. In that case, it'd be in quadrants 1 and 4. Okay, for arc cosine, the domain is -1 to 1, inclusive, and the range would be 0 to pi. And then my quadrants is in quadrant 1 and 2. Okay, for arctan, we have -infinity to +infinity for the domain, and my range here is -π/2 to π/2, and that's in quadrants 1 and 4. Okay, so here's some comments from something I saw in the homework. So here's some reminders for you. When you evaluate an inverse trig function, make sure that your input, your x, is a ratio. This is a ratio. And your output, my y value here, is an angle. Okay? So don't switch them apart. Don't switch them around. So domain is strictly your x value is going to be a ratio. And for your range, for your output, whatever you get out of this, my y, is going to be in an angle. Okay? Very common that you guys mess that up. But make sure you follow the notation and it should be okay. If you have questions, let me know. And the second thing, this is very important, okay? Your output y must fall within the range, okay? So this is what you have, -π/2 to π/2. That means my angle must be between somewhere in here, okay? So for example, if your answer is in quadrant 4, that means when sine or tangent is in the negatives, make sure the angle you get is a negative angle. Okay, if it's in quadrant 4, let's say it's a 45-degree angle, it would be -π/4. Okay, and make sure the angle is between -π/2 and 0. Okay, because you're starting from somewhere like over here. Let's draw this up. So if you have something like that, that means you can only come this way. If you come from 0, negative. Okay, if you're going that way, it's positive. That's for tan and sine. Arctan and arcsine. Okay. Now, if you are in quadrant 2, make sure your angle is between π/2 and pi. If it's not within that value, then your angle is going to be wrong. Because this stuff here, what we're going to do, we've been doing so far, you can do it with your calculator as well. Okay. So this is just to help you. So for cosine in this situation would be from all the way over here. So make sure it's between 0 and pi, and π/2 and π/2 to pi. So make sure it falls within this category. So for quadrant 1, it's between 0 and pi. For quadrant 4, it would be from -π/2 to 0. If it's in quadrant 1 and 2, just go from 0 all the way to pi. And then if it's in quadrant 1 and 4, and again, it's going to be, if it's in quadrant 1, 0 to π/2. And then for quadrant 4, it would be -π/2 to 0. Okay? So keep that in mind. Now, for today's lesson, we're going to talk about reciprocal functions, the inverses of arc cosecant, and arc cotangent. Okay, so this is the next thing that we're going to cover. So to begin with, let's talk about y equals arc. Well, let's look at y equals cosecant. Okay, this is the graph of what the first cycle is going to look like. But again, if you use a horizontal line test, it doesn't pass. In that case, you have to erase something to make it work. In that case, again, we want to stay as close to 0 as possible. So this is what we have. Now, this is 1 to 1. But remember, we have an asymptote over here. So we have to make sure we say that in our domain. So in this case, from this point here to this point here is π/2 negative to π/2. Okay, so now we have restricted our domain to make this work. So that means my domain for cosecant in this situation is going to be from -π/2 to π/2, excluding number x equals 0, because at that point you have an asymptote and that doesn't exist over there. Now, my range here is, the number here we begin with here is -1 and 1. So anything is possible except numbers between -1 and 1. And that's why we have -infinity to -1. Okay, that's this part. And then from 1 to infinity. Okay, everything except -1 and 1. Now, as a result, my domain for in my inverse function is going to be an angle. It's going to be a ratio. Okay, and my range here is going to be an angle. So in that case, we have negative infinity to negative 1, and then 1 to infinity. Okay, make sure these are all square brackets, okay? Square brackets. Okay? Now, my range here is also similar to this, except now because you're looking at range, it's going to be, instead of x, it's going to be a y value. So as you can see here, it's a negative infinity, negative pi over 4 to pi over, negative pi over 2 to pi over 2. That means we are again in quadrants 1 and quadrants 4. Okay, next part, secant. Okay, let's look at what secant looks like. This is what we have. This is a cycle and a half of it. That means if we want to break this up, make this 1 to 1. Okay, so in that case, let's stay away from the negative. So let's erase this side, and then let's erase this side, and then erase this side. Now, this passes the horizontal line test. Now, this is what we're going to have to use. So that means we're going to start off with 0 to pi. And again, very similar. We're going to have, my numbers here are going to be positive 1 and 1. Okay? So as you may have already noticed, we have an asymptote in between. So that means the number here we have to exclude is pi over 2. That's a number we have to exclude. Okay, so this is x equals 0. Okay? Now, so what we're going to have here is, my domain is for this situation, because we want to find the inverse. We have from 0 to pi, this is what we have, and we have to exclude pi over 2, because cosine at pi over 2 is equal to 0. Because of that situation, if you 1 over 0 doesn't exist, therefore we have a vertical asymptote. Okay, so make sure you exclude pi over 2. Notice, oh yeah, this is supposed to be square brackets. Okay, these are square brackets. Okay, so make sure you make that change. So that's the same thing for cosecant as well. Okay, keep that in mind. Okay. Okay, so this is what we have. Okay, now that we've done this transformation, again, my domain range is going to flip. Okay, so my domain for this situation is to be numbers negative infinity to positive infinity except numbers between 1 and, negative 1 and 1. Okay, so that's going to be my domain. This is going to be my range for original. Now, my range in this situation will also be the same as this, except we make the change from x to y. And that's what we have over here. So this is in quadrants 1 and quadrants 2. Okay, now the next thing is, the next function is cotangent. Again, for this situation, if you want to restrict the domain for this one to work, because it repeats this way and this way, but we only want to look at one of them. So in that case, this pi here, the first part will pass the horizontal line test. So that means from 0 all the way to pi. Okay, so in that case, that's what we have. Passes the line test. And then because there's no asymptotes between here except over here and here, there's no conflict, so we don't have to exclude anything over here. Except you cannot put inclusive, because at this point there's a horizontal asymptote, vertical asymptote, sorry. My range here, negative infinity to positive infinity. Okay. Now next part is let's look at the arc cotangent, the inverse of cotangent. My domain here again similar, negative infinity to positive infinity. And then my range here is going to be 0 to pi. And remember, because of this, you cannot include 0 or pi. So in that case, it's in quadrants 1 and quadrants 2. As you may have already noticed, cosecant and secant are similar to sine and cosine. Okay, so they're similar. But now for cotangent, it's going to be different. Okay, for cotangent, it's quadrant 1 and quadrant 2. And then for tangent, it's going to be quadrant 1 and quadrant 4. So that's going to be something that we need to talk about in a little bit. Okay, but for now, this is what we have. So in the next video, we're going to talk about some examples. And then that's it. Okay, see you in the next video.